2 assignments ago, we worked on graphing y equals ax squared. And then yesterday, we worked on ax squared plus c. And today, we're going to finish out the quadratic ax squared plus bx plus c. So how do you graph a quadratic that has all of the pieces? Okay. Well, if you turn to section 3.3, we'll find out what we need to do. So I'm on page 135. So on page 135, we see these two equations. In A, y equals 2x squared minus 8 and 2x squared minus 8 plus 6. So 2x squared minus 8 and 2x squared minus, 8. Wow, excuse me. 8x plus 6. Okay. Everybody push y equals. And then type in those two equations. And then graph them. Oops. I need to change my window. So there's 2x squared minus 8x. And here is 2x squared minus 8x plus 6. Okay. What do those do to the graph? What does A tell us about the graph? It tells us two things. What does that positive 2 tell us about the parabola? It's twice as tall, and it's positive, which means it opens up. So if I had y equals 2x squared, that graph would start here at 0, 0. And then how do I graph 2x squared? Over 1, up 2, over 1, up 2. And it's a parabola that's twice as tall as the parent function. All right? What if I did 2x squared minus 3? How does that change the graph? It's exactly the same shape, but it's lower. It's down 3. So I can take this parabola and I can move it down 3. So in our generic equation, A tells us two things. A tells us which direction it opens and how tall or short the parabola is. Everybody understands that, right? What does C tell us? Do we move the vertex up or do we move the vertex down? So C will move the parabola up or down. Okay? And now today, we are going to introduce B. What does B do? Well, B takes the graph and slides it sideways. Okay? So, C tells me where the graph hits the x-axis, or sorry, the y-axis. So, in y equals 2x plus 0, the red one, we hit the y-axis at 0. In y equals 2x squared minus 3, we hit the y-axis at 3. But up here, at 2x squared minus 8x, I'm still going to hit the graph at 0. Or sorry, hit the y-intercept at 0 because there's no c value. So what does this negative 8 do? It actually slides us to the right. It can't go straight to the right because the y-intercept is supposed to be 0. So when I plug in negative 8x, the graph kind of moves like this. And see how I'm still hitting the y-axis at 0? And you can see that in the blue graph on my calculator. And then the second one, 2x squared tells me that it opens up and it's twice as tall. 6 tells me where it's going to hit the y-axis. So 1, 2, 3, 4, 5, 6. So I could draw this parabola. And then the negative 8x tells me that I'm going to move to the right. Why would I move to the right? Because negatives and x's work backwards. So I'm going to move to the right, and as I do that, I have to keep the y-intercept at 6. So the question is, how much do I move? Well, if I look at the graph, how far did this graph go to the right? The blue one, or the red one. How many x values did it move to the right? 2. So where do we get that number 2? How do I know how far to move it to the right? Well, there's a formula. And that formula is going to be on page 3.3. And the formula says this. The x coordinate, so the x value of the vertex, is found in the equation x equals negative b over 2a. That tells us how far the vertex moves to the right or to the left. Okay? So if I had x squared plus 6x plus 3, how am I going to graph that? Well, first, what shape is this parabola? Is it tall? Is it short? If this number's a 1, what shape is the parabola? Anybody know? No? Uh-oh. Did we not understand the last 2 days? So if I have 1x squared, what shape is this parabola? It's normal opening over 1, up 1. So if I draw my graph, I'm going to go over 1, up 1. So that is the shape of it. What does this plus 3 do? It moves it up 3. So the y-intercept is going to be 3. So I move this graph up to there. Okay. What is the plus 6 going to do? It's going to move it to the left. So this parabola is going to stay hitting that y value right here. That intersection is not going to change. So I'm going to move it to the left. The question is, how far to the left should I move it? Well, I plug in the formula, negative b over 2a, and that tells me how far to the left it moves. So what is b in this equation? So negative 6 over 2 times a, which is 1, and I end up with negative 3. So my vertex needs to move left 3. So 1, 2, 3. My vertex needs to move right to here. So I grab the graph and I keep pulling it until I get 3, and it still needs to hit that y-intercept. So the vertex is -3 comma what? How do I find the y value of the vertex? Plug in -3. So let's plug in -3. What is -3 times -3? 9. What is 6 times -3? 8, -18. 9 minus 18 is -9 plus 3 is -6. So I move this to -6. So about right here, and you can see that it's going to hit the y-axis exactly where it hit it before. Okay? Now, a couple things about this graph. The vertex is -3, -6. Where is the axis of symmetry? Which line divides the parabola into two identical halves? Well, it's this line right here. Okay? Is that an x equals line or a y equals line? Does it hit the x-axis or does it hit the y-axis? Hits the x-axis. So the axis of symmetry is x equals -3. Okay? Does this parabola have a maximum or a minimum? It has a minimum. What is the lowest value? -6. So the minimum is going to be y equals -6. What is the domain of that parabola? All real numbers. What is the range? So the lowest value is -6. Everything from -6 up. So the domain would be all real numbers. And the range is going to be -6 to infinity. Oh, this is actually a bracket. Okay. Do we need to do increasing and decreasing? That doesn't look like it. Okay. We need to remember that the x value of the vertex is -b over 2a. What if I had the equation y equals 3x squared minus 6x plus 4, and I wanted to find the vertex? How do I find the vertex? Well, we know that this graph is super tall. Oops. So up one, over 1, up 3, over 1, up 3, here and here. Okay, and then the plus 4 is going to start us up here at 4. So that will always be the y-intercept. And then what is the -6 going to do? It's going to move it to the right. So we use the equation -b over 2a. So the opposite of -6 over 2 times 3. So it's -6 over 6 with the negative out front, which turns into 1. So x equals 1. We move to the right 1. So we move to the right 1, and it still has to hit in the same place. Okay. So my vertex is 1 comma what? Well, plug 1 in. 3 times 1 squared is 3, minus 6 times 1. So 3 minus 6 is negative 3, plus 4 is 1. So the vertex is 1 comma 1. Where is the axis of symmetry? X equals 1. The line that cuts the parabola in half is x equals 1. Does this have a maximum or a minimum? It has a minimum at, so the minimum is y equals 1. And then what is the domain of this function? All real numbers. What is the range? From 1 to infinity. Okay. Let's do another one. Are they going to throw in some fractions? Yeah, they are. Y equals negative 5/3 x squared minus, I don't know, 6x minus 4. You don't have to graph this to come up with the answers. I know that my x value is negative b over 2a. So my vertex is going to be negative b over 2a, comma, whatever the y value is. So I'm going to plug in the formula. And whenever you're plugging in fractions, I would use parentheses. So we're going to take the opposite of negative 5/3, and we're going to divide that by, oh, sorry, that's wrong. So the opposite of negative 6, and we're going to divide that by 2 times negative 5/3. And I get negative 1.8. And if you push math fractions, you're going to get negative 9/5. Is anybody confused how I plug that in? The opposite of b divided by parenthesis 2 times negative 5/3 gives us negative 9/5. So right here, negative 9/5. Wait a minute. Shouldn't that be? Oh, never mind. Nope, that's right. Okay. How do I find the y value? Plug that into the equation. Again, with a fraction, you need to put parentheses. So I'm going to stick negative 9/5 in here and in here. So negative 5 over 3 times negative 9/5 squared minus 6 times negative 9/5 minus 4. And I get 7 over 5. Now, I haven't drawn the parabola yet. Where is the axis of symmetry? Where is the axis of symmetry? It's this right here. X equals negative 9/5. Does this have a maximum or a minimum? How do you know it has a maximum? It's a negative parabola. It's upside down. So the maximum is at 7 over 5. Okay, so we know that the parabola is upside down, and it looks something like this. Oops, something like that. Here's the axis of symmetry. Here's the maximum. What is the domain? All real numbers. What's the range? The range would be from the bottom up, negative infinity to 7/5. Now, if you don't understand the negative b over 2a, that's okay. You can always graph it. So turn on your calculators. and graph negative 5/3 x squared minus 6x minus 4. So if you struggle with this algebraic manipulation, that's okay. You can always use your graphing calculator. So I have this graphed. How do I find the vertex? If you push second calc, which one of those functions is going to find the vertex for us? 0 will tell me where it hits the x-axis. Intersect is going to tell me where two different graphs hit, and I don't have two graphs. So which one should I use? Value will tell me any number I want. So you would like plug in 8 and get your answer. The vertex is either the maximum or the minimum. In this case, it's going to be a maximum. Everybody understand that? So we will go to maximum, number 4, and it's going to ask us 3 questions. Left bound, right bound, guess. What does it look like our answer is going to be? It looks really close to -2, right? So I can plug in for my left bound like -4. And for my right bound, I can plug in, say, 1. Is my answer between those two lines? Yes. So I'm going to guess -2, and I get -1.8, comma 1.4. So I have this, and I know that this point is -1.8, comma 1.4, and then you can use those numbers to answer the questions. The axis of symmetry hits the x-axis at -1.8. This one has a maximum at 1.4, and then you can do the domain, and then you can do the range. Yes? Anything to the right. So when you're doing left bound, right bound guess, so here is my graph. The answer is right there for the x value and right here for the y value. So we want to pick some number to the left of the x value. So we want to draw a line, and it doesn't really matter where that line is as long as it's to the left. So this one's going to look like that. And then this one's going to look like this. So the left bound can be anywhere over here. And the right bound can be anywhere over here. Now, if you mix them up, what's wrong with that? The arrows are going in the wrong direction, and you're going to get an error. So all you have to do is pick some number to the left of here. You could pick that or that. Anything over here is going to work, and anything over here is going to work. Just make sure that the answer you're looking for is between those two arrows. So this will give me an answer, but it's just going to find the biggest one, which is right here. And that's not what we want. We have to make sure that we capture that vertex. Does that make sense? So if it looks like the answer is -2, you could plug in -2.5 or -3 or -8. You have to stay on the window, though. If you plugged in -100, it will give you an error because -100 is not on the screen. Does that make sense? Okay, so you can either use the -b/2a method to find the x value, or you can graph it in your calculator and then either use maximum or minimum to figure out the vertex and then answer the question. And sometimes they'll want the axis of symmetry, sometimes they'll want the domain, sometimes they'll want the range. So you just have to read the instructions and figure out what the book is asking for. So in set 3.3, we are going to do 3 through, let's do 3 through 27 odd. Okay, good luck.